Okay, here's a wild thought. What if the way an AI learns to understand a movie is actually mirroring a hidden, almost forgotten pattern of human thought? We're about to explore a really surprising connection between artificial intelligence and the deep architecture of our own minds.
So let's start with a question that's really pushing the boundaries of tech right now. When an AI watches a video, what does it actually see? Is it just processing a bunch of pictures one after another? Or is something way deeper happening under the hood?
See, it's not enough for an AI to just, label things. That's a car, that's a person. The real breakthrough, the thing everyone's chasing, is for it to understand the story, the context, the cause and effect happening over time. We're talking about a huge leap from just seeing stuff to actually reasoning about it.
All right, so here's what we've got on tap. We're going to start with AI's biggest challenge. Then we'll dive into a sophisticated reasoning engine. We'll build a bridge to human cognition, talk about the strange logic of base 13, and this idea of recursive leaps. And finally, we'll see how these two frontiers share one incredible pattern.
Okay, let's jump right in. First up, understanding why video is such a massive hurdle for AI. To really get the big picture here, you have to appreciate just how incredibly difficult it is for a machine to watch and understand what's happening, even in a short clip. The AIs built for this are called video LMMs. Basically, think of them as systems that can both see the video and think about it using powerful language models. It's this combination of vision and language that's key to making any sense of what's on screen. But here's the thing. To really get what's happening, these models can't just be passive cameras. They've got to evolve into something way, way more sophisticated. And this is exactly why it's so tough. The AI has to track how things move and interact through both space and time. It needs a long-term memory to connect what happens at the beginning of a video with what happens at the end. Plus, it's got to juggle all this with sound and text. It's just a gigantic puzzle to solve.
So this is the critical point for the AI side of things. These systems have to go from just being perception tools to becoming these sophisticated reasoning engines. And that doesn't just happen. It takes a ton of very specific post-training to get them there, to teach them how to connect the dots.
Okay, so keep that idea of a reasoning engine in your head, because now we're going to completely shift gears. We're moving away from AI understanding the outside world and diving deep into the complex internal world of human thought. Let's see if we can find a parallel.
And this brings up a really fascinating question. What if there's a human cognitive system out there that's structured to tackle a similar level of complexity, but on the inside? This leads us to a framework called prismatic cognition, developed by Dennis Verhaage. It's a unique model for how the mind works, one designed specifically to handle massive internal complexity.
And this really lays out the core analogy perfectly. You've got AI trying to handle the complexity of the external world, all that video data. And then you have this model, prismatic cognition, which is designed to handle the complexity of our internal world, our own cognitive states. So how does a system like this even work? Well, to get prismatic cognition, we have to look at its foundation. It's its unique operating system for thinking. And believe me, it's not what you'd expect.
The entire system, the very logic of it, is built on the number 13. Yeah, you heard that right. Not base 10, which is, everywhere, but base 13, a prime number.
And this isn't just some arbitrary choice. The theory states that base 13 logic is the absolute essential conceptual pillar for the whole framework. It's the key to how this whole thing functions.
So, why base 13? Well, it's a prime number, sitting right between 12 and 14. But more importantly, it's said to provide the perfect computational structure for recursion. Because it's a prime number, it's indivisible, which supposedly gives it a really stable anchor for complex projective thinking. It's that recursive quality that's really the secret sauce here.
All right, so if base 13 is the foundation, how does this system actually grow and learn? It's not about taking baby steps. It's about making these incredible leaps.
Okay, so a simple linear progression is just adding 1, right? You're at I, you go to I plus 1. But this system proposes something different, a recursive progression. That arrow from I to I plus 1 isn't just addition, it's a contextual leap. It means the next step is determined by the entirety of the current state, not just the last piece.
And this is where it gets crazy, because this concept is directly validated by the core mechanism in AI language models, something called next token prediction, or NTP. It's exactly how they work. An AI doesn't just guess the next word. It analyzes the entire context to predict the most probable next token. It's a perfect parallel. And inside the prismatic cognition framework, this recursive rhythm is tied to a really human idea, incremental, daily renewal. Think of it like this. Every day you wake up, and you're not just adding one new piece of information, you're building on the entire context of the day before.
Okay, let's bring these two frontiers together and look at the whole picture. On one side, you've got AI and its reasoning engines. On the other, you've got this model of human cognition. When you synthesize them, the pattern is, well, it's pretty amazing.
So just look at this side by side. The domain is different, sure, external video versus internal thoughts, but the core challenge, it's reasoning about complex relationships, the foundational logic, a sophisticated architecture, whether it's a language model or base 13. And the mechanism, both use a complex recursive progression, not just simple addition. The parallels are just undeniable.
And really, this is the big idea here. It suggests that the architecture for advanced reasoning, whether it's happening in silicon or in our synapses, might actually follow some very similar structural principles. The how of complex thinking might be universal.
Which leaves us with one last question to chew on. If this hidden logic shows up in both cutting-edge AI and a model of the human mind, what other complex systems out there might share it? It makes you wonder, doesn't it?